Next, we consider the voltage divider configuration circuit without the bypass capacitor. So the difference is we remove the bypass capacitor. Okay, there is no bypass capacitor. So what will happen? So in this case, we consider the RD is equal to infinity. Okay, and then what you need to write down the equation. Draw the AC equivalent circuit and write down the equation for ZI and Z out as well as AV. Okay, so the AC equivalent circuit. So the AC equivalent circuit. Okay, again we start from the input here. This is your VI, and then at this node we have the R1 and R2, both the terminal, another terminal is connected to the ground. So we have here, this is R1, this is your R2. Okay, and then at the gate, between gate and the source, we have an open circuit here. This is your VGS, and then at the source, okay, since there is no bypass capacitor, so RS will appear. Okay, at the source, between source and drain, we have the voltage dependent current source. This is GM VGS, and then since RD is infinity, so no need to draw the RD. Okay, and then the drain, we have the RD and the output terminal. So this is your RD and this is your output terminal. So this is the AC equivalent circuit. Okay, so let me draw it again. So right now we can simplify the R1 is parallel with R2. This one R1 is parallel with R2, and then we have this is the RS okay. So what is the input impedance? Okay, the input impedance will still be R1 equal to R1 parallel with R2. So input impedance is R1 parallel with R2, because the connection here is we have the open circuit between the gate and source. There will be no physical connection. So R1 input is R1 parallel with R2. How about the output? So for the output, it's still equal to, it is equal to RD. This is because for the output impedance calculation, you consider the input is short circuit. When the input is short circuit, what happened to the VGS here? VGS will also become 0, and then the GM VGS will become 0 ampere. It's open circuit. You will only see the RD. Okay, how about the AV? So for the AV is this is VI. AV is V out over V in. So V out is the voltage across the RD. So this is minus GM VGS RD. So this is V out. For the V in, so the V in is the voltage from at this point. Okay, voltage at this point. This is also a V in. So voltage at this point will equal to VGS, voltage at VGS. This is not grounded, so you need to plus the voltage drop at the RS. Okay, voltage drop at the RS is using the Ohm's law, the current times RS. The current at the RS is equal to GM VGS. So you have GM VGS RS. Okay, so therefore you get the AV is equal to minus GM VGS RD over VGS plus GM VGS RS. So this is minus GM RD over 1 plus GM RS. So this is the equation for the voltage gain. So you see the difference between the circuit with the bypass without the bypass. The significant difference is the voltage gain. So the voltage gain without the bypass, you need to divide with the 1 plus GMRS. So means that without the bypass capacitor, the gain will decrease significantly. So you need in order for you to have a better amplification, you need to have the bypass capacitor.